So in order to apply the knowledge on errors and approximations, we're going to look at some questions. And here, our first question is: Alex has a rectangular plot that was measured to the nearest meter and found to be 80 meters in length and 60 meters in width. Determine the percentage error in its area to one decimal place. And we've been given 3 marks. So here, for us to be able to get this percentage error, we know that the percentage error shall be given by the relative error multiplied by 100%. But now, for us to get to the relative error, we need to take the absolute error. We divide by the actual. And then now here, we can multiply by 100%. So here, for us to be able to get the absolute error, we need to get the maximum area and then take away the minimum area, and then now that we divide by 2. So our task here is first of all now to get the maximum area and the minimum area. So when we look at our question, we have to ask ourselves, where did the error occur? The error occurred when we were taking the measurement. Note that the measurement is measured to the nearest meter. And so this means it is to the nearest whole number. So this means that our least count, or the instruments that we use to measure these distances, the smallest value that they could take was unit, that is 1. So to get the absolute error in that measurement, then we divide 1 by 2, so that we see that our absolute error in the instrument was 0.5. And so this means that all these measurements that have been taken, for example 80, it is 80 plus or minus 0.5. The measurement 60 is also 60 plus or minus 0.5. And this means that now for us to get the maximum, we shall take 80 plus 0.5. To get the minimum, we subtract. So to get the maximum area, we know that area is given by length multiplied by width. And so here, the actual is just going to be 80 multiplied by 60, which is now 4,800. And now to get the maximum, here, for us to get the area we are multiplying, so there we use propagation of errors, whereby we said now that for you to get the maximum product, you take the maximum of the first value multiplied by the maximum of the second value. So we take the maximum of the length multiplied by the maximum of the width. So the maximum of the length is now going to be 80.5, and the maximum for the width is going to be 60.5. Then in order to get the minimum, we are going to take the minimum of the first value, that is the length. So we take 79.5, and then we multiply that by 59.5. And so when we work out here, 80.5 times 60.5 gives us 4,870.25. And when we work out 79.5 times 59.5, that gives us 4,730.25. So in order to get the absolute error now, we take the maximum area, 4,870.25, and this we subtract 4,730.25, and all that we divide by 2, so that in this scenario now we are going to obtain our absolute error in the area, which is now 70. So now in order to get the percentage error, we take our absolute error in the area 70 divide by the actual area, which is 4,800, and then now we multiply that by 100%. And when you multiply that by 100%, that gives us approximately 1.458. And our question directed us that we write our answer to one decimal place. So this is approximately 1.5%. In our second question, a metal cylinder has a height which is exactly 10 centimeters. Its radius, measured to the nearest millimeter, is 3.5 centimeters. Find, correct to 4 significant figures, the percentage error in calculating its volume. So here now, we want the error in the volume. So in order to get the error in the volume, we very well know that the percentage error is given by the relative error multiplied by 100%. And for us to get the relative error, we have to take the absolute error, and then we divide by the actual. And so that now we can be able to get the absolute error, we have to take the maximum volume, take away the minimum volume, and then all this we divide by 2 in order to get the absolute error. So here, for us to get the maximum volume, and then we also get the minimum volume. For us to get the maximum volume, we use the maximum radius. For us to get the minimum volume, we use the minimum radius. When you look at the measurement 3.5, it is measured to 1 decimal place. Since it is measured to 1 decimal place, it means the instrument used had a least count of 0.1. And so to get the absolute error in the instrument, we are going to take 0.1, we divide by 2, so that we find that the absolute error in the instrument was 0.05. So this measurement 3.5 is plus or minus 0.05. So this means the maximum we add, the minimum we subtract. So we know that the volume again is given by pi r squared multiplied by the height. So in this case now, for us to get the maximum volume, we are going to take pi, and then we multiply by the maximum radius, so 3.55 squared, and then we multiply by the height, which is now 10. And for us to be able to get the minimum volume, we are going to take again pi, we multiply by our minimum radius, and then we multiply by the h, which is 10 again. So here, when we work out, we are going to find out that our maximum volume is going to be equals to 126.025 pi. And here on the minimum, when we work out, we are going to find out that our minimum volume is going to be 119.025 pi. And then now we can be able to find out what the actual volume is. So the actual volume is going to be pi, we multiply by 3.5 squared, then we multiply by 10. And our actual volume is going to be equivalent to 122.5 pi. Then now we can proceed and find our relative error. And first, before we find the relative error, we get the absolute first. So we take the maximum, 126.025 pi. We take away the minimum, which is 119.025 pi, and then all these we divide by 2. So when we work out that, we are going to find out that our absolute error here is going to be equivalent to 3.5 pi. So now we take our absolute error, 3.5 pi, we divide by the actual, which is 122.5 pi, and then we multiply by 100% in order to get the percentage error. And when we do this, we are going to find out that approximately our percentage error is going to be 2.857%. In our third question, we are told that the dimensions of a rectangle are 10 centimeters and 15 centimeters. If there is an error of 5% in each of the measurements, find the percentage error in the perimeter of the rectangle. So now, in this scenario, we encounter a different aspect of the errors, whereby we are being told that there is a 5% error in each of the measurements. So this means we'll be required to find out what is 5% of 10 centimeters and what is 15%, what is 5% of 15 centimeters. So we quickly do that. So we find out here what is 0.05, that is 5% of 10 centimeters. And in this case, we are going to find out that it is going to be 0.5. So this means that the measurement 10 centimeters, it is now 10 plus or minus 0.5. Then we also find out what is 5% of 15 centimeters. So we take 0.05 of 15, and we're going to find out that this is 0.75, meaning that the measurement 15 centimeters is now plus or minus 0.75. And hence, we can now go ahead and now calculate the perimeter. And in order to get the percentage error in the perimeter, we shall require the maximum perimeter, we shall require the minimum perimeter, and also the actual. So we know that the perimeter of a rectangle is given by 2 in brackets length plus width. And so we know here that the actual is going to be twice 10 plus 15. And so this is going to give us 50 centimeters. And then now, so that we can be able to get the maximum, so here what we shall be doing is we are adding the two units, or we are adding the two measurements, that is the length and the width. And so in order to get the maximum sum, we require the maximum of the length and also the maximum of the width. Hence, our maximum perimeter here, in order to obtain our maximum perimeter, we are going to take 2 in brackets. So to get the maximum length, we add 0.75 to the 15, so that we have 15.75. And then to get the maximum width, we add the 0.5 to 10, so that we have 10.5, and we sum that. And so when we sum that and multiply by 2, we are going to have 52.5 centimeters. And then we can proceed to the minimum. So in order to get the minimum sum, we say that we take the minimum of the length and the minimum of the width. And so in order to get the minimum of the length, we take away 0.75 from 15, so that we can be able to obtain 14.25. And in order to get the minimum for the width, we take away 0.5 from 10, so that you can be able to obtain 9.5. And so in this case, when we work out, we are going to obtain 47.5. And so this becomes our maximum perimeter, 52.5, and 47.5 becomes our minimum perimeter. So we work out the absolute error. So we know the absolute error is going to be the maximum, take away the minimum, and then we divide by 2. And hence, when we substitute here, we are going to have 52.5, we take away 47.5, and then we divide by 2. So that now here we can be able to obtain our absolute error as 2.5. So once we find out that our absolute error is 2.5, we can now proceed and find out what our relative error is and also our percentage error. So to get the relative, we take the absolute 2.5 and then we divide by the actual 50, and then we multiply by 100% so that we can be able to obtain the percentage error. And so when we do this, we're going to find out that our error is going to be 5%. In our fourth question, we are told that the measurements A equals 6.3, B equals 15.8, C equals 14.2, have maximum possible errors 1%, 2%, and 3% respectively. So we want to find the maximum value of A multiplied by C, and then all of them divided by B. So here, we need to remember our knowledge on propagation of errors, and our question here requires us to find what is the maximum of now the product of A and C divided by B. And so, for us first to obtain the maximum quotient, in the numerator, we shall require the maximum. So here, this means that we shall require the maximum of A times C divided by, in the denominator in the quotient, we shall have the minimum. So we divide by the minimum of B. So this means, for us to obtain the maximum product in the numerator, we are going to multiply the maximum of A by the maximum of C in order to obtain the maximums. Then in the denominator, since it is only one value, then we're just going to have the minimum of B. And now, since we've been given the respective errors for the various measurements, then we're going to apply that. So in order to apply the maximum of A has got an error of 1%. So that means it increased from 100% to being 101%, which is now basically 1.01 in decimal form. So in order to obtain the maximum for A, we multiply 6.3 by 1.01. And then now that one, the maximum of A, we multiply by the maximum of C, and we've been told that the maximum possible error for C is 3%. Hence, we add the 3% to 100% in order to get 103%, which means in decimal form, that is 1.03, and so we multiply with the value for C in order to obtain the maximum. Then all these we divide by the minimum for B, and in this case now, the minimum for B, we take away 2% from the 100% in order to obtain that the value of B now after the error on the minimum side is going to be 0.98. That is 98%. And then you multiply by the value of B, which is now 15.8. And now, when you work out this, you're going to obtain 6.0104. And hence, this is going to be the maximum value of the product AC divided by B. So in our fifth question, we've been told that by rounding each number to the nearest tens, approximate the value of 2,454 multiplied by 396, or that divided by 66. Hence, calculate the percentage error arising from this approximation to four significant figures. So in this particular case, first we need to get the actual value by simply multiplying these numbers, and so that way now we shall be able to get the actual value. And so when you multiply this number, you're going to find out that the actual value is 14,724. Then you round off the numbers to the nearest tens. So when we round off 2,454 to the nearest 10, we're going to obtain 2,450. And also when we round off 396 to the nearest 10, we are going to obtain 400. And also when we round off 66 to the nearest 10, we are going to obtain 70. Then when you work out this, the rounded value is going to give you 14,000. So now here, our absolute error is now the difference between the rounded value and the actual value. So we take 14,724, we take away 14,000, so that now we can be able to obtain the absolute error. So in this case, we are not going to find the maximum and the minimum, since here the error is not coming from the measurement, the error is coming from rounding off. And so when you're rounding off, the absolute error is the difference between the rounded value and the actual value. So we just proceed here with our absolute error to find out what our percentage error is going to be. So to get the percentage error, we get the relative by taking the absolute error 724. We divide by the actual value. Our actual value here is 14,724. And now this value we multiply by 100% so that we can be able to obtain the percentage error. So to get the percentage error to four significant figures, it's going to give you 4.917%. In our sixth and last question, we are told a tailor decided to subdivide a piece of material into 6 parts. When making the measurement, she truncated it to two significant figures. Calculate the relative error due to this truncation. So here now, when she divided the material into 6 parts, it means that now she was supposed to obtain 1 out of 6, or a sixth. But now, a sixth in decimal form is going to be equivalent to 0.16 recurring, which is the same as having 0.1666 infinity. And so now, in this particular scenario, if it is truncated to two significant figures, we are going to obtain 0.16. So here, in order to obtain the relative error, we know that to obtain the relative error, we take the absolute error and then we divide that by the actual. So our absolute error here is going to be, we take the actual, which is supposed to be 1 out of 6. We take away 0.16, but now in fraction form. In fraction form, 0.16 is going to be equivalent to 16 out of 100. And so now when we work out this, we are going to find out that this is equivalent to 1 out of 150. So this is going to be our absolute error. So to obtain the relative, we take 1 out of 150, our absolute. We divide that by the actual, which is a sixth. And so in this scenario, we're going to have 1 out of 150, and then we can multiply by the reciprocal of a sixth, which is 6 out of 1. And here now we are going to obtain our answer as 0.04. So this becomes our relative error.